Hello, everyone. Welcome back to Stardust Discovery with the Astro-Princess. I'm excited to bring us an exciting topic today. It's one of those natural events that happens, and that's why I like it. I'm sure maybe some of you have heard about Aurora. So I want to talk about Aurora today. So thinking about it, I'm excited because it's only visible from some parts of the earth, and I have not seen one physically with my naked eye, but I think I'm a bit closer to seeing it. So hopefully I should be able to see an aurora soon. So what are auroras? So we are going to look into the different interesting aspects of aurora. Why is it exciting? Why am I fascinated by that? The different interesting ways people think about it. Actually, people have myths and culture around aurora, but there is a science explanation to aurora itself. There's a reason why it happens, which is part of what we'll be talking about. In fact, that's the major part of this video, and I hope that by the end of this video you will learn the different types of aurora, why they look the way they look, the different cultures surrounding aurora. You will learn about what causes aurora and how you can picture aurora. It's interesting to be able to capture one if you can maybe go to the region or the location and even photograph it. So it's interesting to be able to do that. So that's what I hope we could achieve by the end of this video. But before we move forward, I just want to remind you that this page is about learning the environment, understanding why things happen the way they are. So I would encourage you to subscribe to this channel. Share the videos if you like them, and of course like the comments. Like the videos, comments when you need to, and let me know if maybe the questions that we've answered so far and things you have been looking forward to answers to, and also ask some other questions. We may not know, we are here to serve you, so when you ask those questions I will make videos of them. So yeah, I'm looking forward to seeing your comments, and those will be useful feedback for how we proceed going forward. Okay, so we're back to aurora. So the actual definition of aurora, it can come in different ways, but the real thing is that it's actually an eventful lightning, usually greenish in color, that happens at the polar regions of the earth. It happens around the northern region, the northern hemisphere of the earth, when you consider Russia, Canada, all those regions, Norway, Finland. So the countries around the polar regions, those ones will be able to see an aurora. Then in the south, you also have all of those ones towards the South Pole region. They also can experience an aurora, and in particular they have a unique name for whether they are from the south or from the north. So if you have heard about aurora borealis, that's the northern one. We call it northern lights. And there is the aurora australis, which is the southern light. So take notes when next you hear about aurora, you can imagine what they are. So it's an interesting event that happens almost all year round, but there are times where they are most visible, and depending on whether you're in the north or south, I will be sharing some of those in this video. So having gotten an overview of what aurora is, I will be showing on the screen shortly as I explain a little bit in detail. What causes aurora? I think it's important that we understand the science behind aurora. What causes aurora to happen, right? So first thing I would like to explain the concept of space weather. So in space, there are different things that happen, and the closest thing to us right now outside our planet is the sun. And what happens in the sun sometimes affects us. In fact, the light that we see during the day comes from the sun, right? So the sun is really close that some activities that happen around or in the sun gets to us. Not in a bad way, so do not be afraid. But yeah, so it's part of space weather. Whatever activity is happening in the sun is classified into space, right? So, for example, when there is intense magnetic field going on in the sun, magnetic field activities, so there are sometimes, you notice some of the sunspot regions appearing more often and even creating more dark spots than usual. Those are some of the ways we know that there is an intense activity, and they have been studied over time, so they actually can be timed. So we now know the time where you can expect an intense activity, and we'll be talking about that in a bit, because that's another way to know when you should expect an aurora to be more visible or not. So, and during those times of intense magnetic field activity in the sun, it usually accompanied with tons of particles, or what we call plasma, but plasma actually just means hot and charged particles, are being thrown out from the sun as a result of the magnetic field activities being intense. Now, these events, we usually call it solar wind when it's just normal. But when it's very intense, we call it coronal mass ejection, because the amount of material that will be released could be much more compared to a normal solar wind. All right. So this process releases a ton of materials from the sun into space, and as they travel into space, they could take maybe 2 to 4 days to get to Earth, depending on the inclination the sun and the Earth is at the time. But they actually travel through space. Some get, scattered by another, light, or get absorbed by other things in between us and the sun. But for some of them that end up getting close, something spectacular usually happens. Right. So I've discussed a bit about the sun and how hot and intense the activities could be in the sun. So, when you're looking at the sun, like on a typical day, what you see is a bit whitish object, but that's because the atmosphere of the Earth is absorbing all the light and turning them to that whitish color you see. The real color, when you take away the atmosphere of the Earth, is like a hot burning charcoal. That's the real color of the sun. So imagine that hot colored sun, like very hot, releasing whatever is burning. If the fuel is burning, it's converted to charged particles, and all of these things gets emitted at some point or released at some point. So, and they travel and they get to Earth and every other object they encounter on their path. So, getting back to Earth. Now, there was one of the videos I've mentioned that the Earth has a very strong magnetic field. In fact, the Earth is a bar magnet. I think it was the last video I discussed magnetic field. So the magnetic field of the Earth emanating from the inside, the molten magma in the inside, creates this blanket. I'm calling it a blanket, but those are actually field lines. So the magnetic field lines form a form of blanket shielding the Earth. So when all these charged particles get close to the Earth, they come in contact with these field lines first. So the field lines they deflect some of the particles. Some of them manage to get in, and those ones that manage to get in, they would, be redirected by those field lines, and they move all the way to the polar regions. Now, when they get to those polar regions, there are some atmospheric molecules and atoms that they would encounter, and those sometimes we see oxygen and nitrogen playing out most of the time, but it could differ. So, but depending on the layer of the atmosphere they encounter, you are going to see different molecules of the atmosphere from different layer fluid to different layer. So the interaction of these magnetic field line, the particles and the particles of the atmosphere creates this aurora event we're talking about. So the colors you see depends on some of these factors. It depends on what element in particular, or what molecule. Is it oxygen? Is it nitrogen? And it also depends on what energy level they are. So there is an excitation that happens. So the charged particles, of course, will excite the molecules of the atmosphere or the atoms of the atmosphere, taking them to higher energy levels. But then as they calm down, as they cool off, they will drop back to their stable state. And that means they will give off that energy. So giving off that energy in form of colors of light. Remember, we have discussed what light is. Packets of energy, packets of electromagnetic energy. So they will give off those colors of light depending on the level where they were before they, step down. The colors they will give off will be different. So if, let's say, the layer was on there's a 200 kilometers, for example, and then it has to go down in energy level. Let's say 100, I'm just using distances, but actually this should be energies. So it would give off different color of light depending on how it's going down. Okay, so let me not take us to that, rabbit hole trying to explain. But what is important is that the different colors we see is caused by the different elements or molecules they encounter on their way, and depending on the height, the altitude where those molecules are, these are the things that affect the different colors that you see. Mostly we see the green, we see the purple, purple or violet lights, usually caused by the nitrogen. The green is usually caused by oxygen. So those are like the most popular colors. And I love those colors so much. So yeah, so this is how auroras are formed. This is what causes aurora. The magnetic field of the Earth interacting with those charged particles from the sun. Now, it's amazing, right? Just imagine that those particles actually get in. Now, remember that the lights or radiation coming from the sun contains all of the spectrum of the electromagnetic light. The X-ray, the gamma ray, the infrared, all of the spectrum gets in. So it is so cool to know that the magnetic field of the Earth is serving as a blanket, because it waves off all of these dangerous radiations from getting in. All the events that happen, the aurora we see, we think is beautiful, those are all the processes, of dissolving or deflecting those particles and not allowing them get in. So, and I find it really interesting that, God could design the universe with so much detail and making sure that the Earth is preserved. Okay, So interesting, right? Now, what are the other interesting things about Aurora? The things I like a lot to, discuss about Aurora is the sound. So there's actually a sound associated with this event. There are some, misconception. People think that it's not caused by the actual aurora, but the environment. People think that maybe it just how thunder also is a sound effect of the lightning itself. So people think that the sound that we think we hear is an effect of the actual event, but it's not necessarily sound. Maybe it's a low frequency electromagnetic radiation, but it's perceived as sound by our brain, like all kinds of things. But anyway, the point is there is a sound, and I think it's interesting. Right. Now, I want to quickly talk about how you can observe or photograph aurora. So, I mentioned the other time that it happens only at the polar regions of the Earth. So that's a general way to first screen where you'll be able to see the aurora. So the geographic location is very important, and I've mentioned people like countries that stand a better chance, like Norway, Finland, Sweden, Canada, especially if you are close to the Yukon and the Northwest Territories, Alaska in the US. All of these regions would experience it. Then in the south, you also see that in New Zealand, the southern island, but in Australia, of course, Samania region, the Antarctica too. So some part of the south will see aurora a lot. Now, around what time of the year is it best to look out for aurora? So I would say that it's visible like in the fall for people in the northern hemisphere. So from September to November period is like the best time, and also in spring from March to April, around the equinoxes, you will most likely, because this is the period where we have experienced a lot of activity with the Earth magnetic field. So you have high activity of the Earth magnetic field. So that is another factor to consider. So because of the high activity of the Earth magnetic field, there is a high chance for aurora to be amplified, so it's more visible. That doesn't mean it does not happen throughout the year. It's all year round, but sometimes it's intense, sometimes it's more calm. All right, so the time of the year is crucial. In the south, months from March to September is good, while in the north, I would say September to March. Okay, then because these things are based on the solar activities and the Earth magnetic field activities, it's also good to look out for the space weather forecast. You can always find information from NASA Space Weather Prediction Center. There are always maybe updates on what we already know. And most importantly, for you to be able to capture an aurora, you need a clear sky. So you don't want to be in the city, you want to go to somewhere without light pollution. So a rural area would even be a best fit for this. So a clear sky, minimal light pollution is your good shot. Then general rule of thumb for observing things in the night sky is to use longer exposure time. So in terms of camera setting now, I would advise you use a longer focal length, use longer focal time to observe the aurora. This will help you to capture the details, and then keep it on a very low temperature, like 3000 to 4000 Kelvin, to maintain the natural colors of the aurora. Like keeping things simple will help you to get the best best results in general. Okay, so I'm just thinking, what are the other interesting things? So different cultures have different attachments to Aurora. From Nigeria, or let's say Africa, because we do not see Aurora a lot, we probably don't have a lot of attachment to them. I, for myself, I do not have any understanding. There are other events we have serious attachment to, and I will be making videos in the future for them, like how do we relate to these celestial objects in our different cultures, because that's an interesting aspect of astronomy. It's called cultural astronomy. You'll find out that we all have been astronomers at some point or the other. In fact, in the past 1,000 years, or 1,000 years ago, many people were astronomers. They just didn't know that's what they are. And every way we interpret these events, they are still valid. It may not be scientifically proven, but our interpretation, our perceptions are also valid. And you'll be seeing in that video that some of those predictions worked for the people and are still working even up till now. But that's not the focus of this. I was just going to mention that the region where they have cultural attachment to auroras are people from the northern region and those southern region. So the northern hemisphere of the earth, because they see it, right? So they would have inclinations and so many explanations to it. So those are the people. I know I have a professor who is an indigenous person. She explained a lot of interesting stories around Aurora connected to their ancestors, which I found very fascinating and interesting. And they still hold on to these things up till now. So this is just for me to, prepare your mind before I even talk about that video, but begin to think about how your community think about some celestial objects or events. How do you interact with them? How do you interpret them? These things, they are a part of us. They form the culture, and I think they are important. They somehow have a way of defining who we are and the kind of people we are. Like if you talk about African people, so some of these events have formed the way we look at ourselves, has formed the way even we do things. So I'm just asking you to go and begin to find out, ask questions, and then hopefully you can relate when I start to talk about this part in our coming videos. Okay, all right. I hope you find this video interesting. Don't forget, we talked about Aurora, the different factors that affect Aurora, what causes it actually. We mentioned the atmosphere of the Earth, the magnetic field of the Earth in particular, but then the interaction of the magnetic field of the Earth with the particles from the sun, those charged particles, these things, what causes Aurora. We also talked about the sound it makes, talked about how you can image or photograph an Aurora, the best conditions, the people that see it the most, the time you should watch out for it, and the locations you can see, so you can actually plan a trip. There is something like Aurora tourism, so people plan to really go and just watch an Aurora. So I hope this all made sense, and feel free to use the comment section to ask specific questions, and then subscribe, like this video if you enjoyed it. And I'd like to hear your feedback, so also use the comment section to give your feedback. Thank you so much, and I will see you in our next one. Bye.